Thanks so much, Sarah. Hi, everyone. Yeah, as Sarah said, so the next sort of 20, 25 minutes of this afternoon, I'm going to give you a presentation which Sarah and I put together. And as she said, we're going to give you a little bit of an introduction to conceptual site models. I kind of want to avoid just simply taking the guidance documents and just turning that into a presentation. What we did instead was come up with what we think are important lessons that we've learned from our experience in the industry with regards to conceptual site models. So my personal aim right now is to give you an understanding of what a conceptual site model is, what it contains and what it is used for. I also want to show you what your responsibility is as a creator or author of a CSM. So CSM, you'll hear me use that a lot. It's basically short for conceptual site model, in case you weren't aware. So let's start off. First thing is, I just want to spend examining the term conceptual site model. Okay. So first of all, it is conceptual. It's a concept or an idea. It isn't a perfectly formed, detailed description of a site or design. It isn't. It's all it is an idea that says, based on the evidence that we've collected from this site, this is how we think it works. This is an explanation of what we see. Now, when it comes to the site, what is meant by the term site here? A site is everything within a clearly defined boundary, typically a site ownership boundary or perhaps a defined development boundary that covers everything from the surface, including infrastructure, buildings, houses, waste management features, all those sort of things, down through the foundations, through the midground, down to the natural superficial deposits and to the bedrock, quite commonly deeper than the bedrock. Sometimes you have fractures and fault lines that can cause conduits for contamination to mobilize. There's also things like old mine shafts, which could present collapse risks or gas risks. So it covers a huge stretch vertically through the Earth's surface. It also includes the land immediately surrounding your site, where the contamination may be affected by external features, or there may be off-site receptors. So think about where groundwater travels underneath the ground and crosses your site boundary. You need to know where that's crossing, where the groundwater is coming in and where it's exiting, as well as things like vapors or napples and those sort of things. So you need to be aware of what your site represents, what it is. And finally, the conceptual site model is a model. And like all scientific models, it is wrong. Our Earth is far too dynamic to be modeled with 100% accuracy by any method or technology we have. What makes a model good is when it's only wrong by a small amount. And in order to achieve that, what we need to know are what parts of our model are supported by data and what parts of our model are not supported by data. What are just assumptions? We need to work to incrementally fill those data gaps in order to improve and make the model better, or another way of saying it is to make the model less wrong. The aim is to get to a point where the parts of the model that are wrong are small enough so that they don't affect the overall model and how it sort of makes sense and how it represents what's actually underneath the ground. This is what we hope to achieve with a conceptual site model. So in summary, it's an idea about how all the features of the site are working together. So first, what is a CSM for exactly? Okay, so first and foremost, it is our representation of a site in the absence of the ability to sort of lift up the top of the site and look underneath at how it all works. This conceptual site model is the next best thing. Anyone with an interest or a stake in the site should be able to pick up your CSM, read it, understand it, and know exactly what's going on beneath the surface. Secondly, it doesn't need to show everything about the site. It needs to focus on what we call source pathway receptor linkages. These are the relationships between the contaminants within the site with an understanding of sort of how they got there, the pathways by which the contaminants are mobilized and can move around your site, and the receptors such as humans, controlled waters like aquifers, rivers, lakes, and also ecological receptors, either within the site itself or maybe adjacent to the site as well. These linkages, these source pathway receptor linkages, show the ways in which contamination may be reaching and causing harm to humans, animals, water bodies outside of the site. Finally, as I've said previously, it is a scientific model. You should also think a bit about this as like a scientific hypothesis, which brings together all of your observations on your data on a site and aims to explain how all of those observations and data fit together in like a single workable and testable idea. I want to examine a little bit more about the source pathway and receptor model, because this is essentially the backbone of the CSM. Being able to clearly show what sources, pathways, and receptors are on the site is going to guide your risk assessments and your remedial design moving forward. And so it's essential to get that right from the offset in order to ensure that you are accounting for all the potential pollution pathways and receptors, and making sure you're accounting for all the risks associated with that site moving forward. So let's have a little look at how you define these individual things. So the source, okay. When identifying and categorizing sources, I find it really useful to use this model, which is the what, where, when, who, why, and how method. This was something I learned, I think it was GCSE history, which was many years ago. But I find this incredibly useful when thinking about sources and thinking about understanding what's the source underneath the ground. So when we apply this to different sources, you think, what are the contaminants? What is present underneath the site? What contaminants they are? How mobile they are? Can they volatilize? Are there any NAFLs? And that sort of thing. So understanding what is in the ground is the first thing to think about. Next thing is where. So where they're located. Are they confined to particular geological units or aquifers? Are they site-wide? Are they localized? So the location of them is obviously the next important thing. When is an interesting thing. When they are introduced to a site is something to think about as well, because if they are fairly new, fairly recent release, you know, they're going to be potentially closer to the surface, probably easy to clean up. If they're older contamination, they've had more time to travel, more time to migrate, but also you have to think about they've had more time to degrade, and you might be seeing what's called daughter products, new products that are forming from the degradation of the original contaminant. So when the source came to be is also quite important. Who is important when we're talking about due diligence or lawsuit work. So if you're trying to figure out exactly who is responsible for a particular contaminant on the site, you've got to start doing a bit of forensics to work out when this, when this contamination was released and who was operating on the site or who is responsible for it. Why is an interesting one, because if the site is an active site, say you want a refinery that's just working, knowing why pollution is happening will allow the responsible parties to fix that problem. So if you know why it's happening, they can go in and they can fix a broken pipe, or they can change their methods to ensure that that pollution problem stops. And how is very similar to that, in that understanding how things occur can help you understand or improve your CSM model moving forward as well. So that's a useful thing. I haven't seen any of the guidance, but that's something that I use and I found it quite useful. So the next thing is a pathway. So how can contamination move from the source to different parts of the site? And within this, you've got to think about how different pathways are let me start that again. Different contaminants can move in different ways. Some can volatilize and move as a vapor phase. Some can dissolve into groundwater and be moved along with groundwater. Some stays as a non-aqueous phase. So that's like an oil product, which can either float on the top of groundwater or perched water bodies, and some can sink down to the bottom of maybe groundwater aquifers. And some are totally immobile as well. Some just sort of sit bonded to the soil. So understand how the different contaminants can move around the site is important. The other thing to think about there is also what features of the site may create preferential pathways. So think about things like utilities, the geology, any foundation structures that could be creating gaps and places that contaminants can easily migrate around the site. So you've got to get a good idea of we'll come to this in a second, but the geology and the subsurface features that could allow contamination to move in its various different phases. And finally, receptors. So receptors may be a human receptor, either living or working on or around the site, a controlled water source such as an aquifer, river, lake, nearby water body, or an ecological receptor, particularly things like conservation areas or areas of scientific importance. These receptors are what we always aim to protect, either by removing or reducing the initial source of contamination, or by breaking that pathway between the source and the receptor. And in order to do this, we need to clearly define what sources, pathways, and receptors are present on the site, which is what essentially the main aim of the CSM is. Let's quickly have a look at what goes into a CSM now. So this is an image which I think we've already sent out to you. This is one Sarah's made, trying to show how all the different types of data that you will collect about a site are the relationships between them and how they build up in order to form the information that goes into your CSM. The reason we've designed it this way is because there's different levels of data, there's different layers of data, and everything along the bottom, or let me put that a different way, each layer of data you can't build until you build the layer below it. So that's why we've done it like a pyramid, so it's a foundation sort of system. So the first layer of data that goes into CSM is essentially everything you'd collect during a phase 1 site walkover, during an initial desk study of the site, all the bits of information you'd gather together, all the regional information you gather together to start to build up a picture of your site. And at this point, you start to think about your CSM. You start to build a CSM. It'd be quite vague at first, but you would start to pull that information together. As you continue through phase 2 into your site investigations, you start to take samples, you start to understand what's underneath the ground. Then you can start to add more and more information to your CSM and start to build the picture of those source pathways and receptors in a bit more detail. And then once you have an understanding of what the contamination is, where it is, and what your potential receptors are and your pathways, then you can start doing a more targeted investigation, the pale blue and the purple on top. The key data which you'll need to do your risk assessments to understand exactly what the risk is from a particular source to a particular receptor via a particular pathway. That should be in your in your handout, so have a good look at that. I haven't got enough time to go through it in detail, but I think we've managed to capture all the different types of data you'd be looking at capturing during a site investigation and add into a CSM for sure. So let's briefly talk about building a conceptual site model. So firstly, building a CSM is not a one-stage thing. It is an iterative process. It is an ongoing building of a model throughout the life of a project. Even once you finish the remediation phase of a project, even once you've done all the construction, you fixed it, your CSM can still be added to, because once you've done the remediation, you know more about the site, you've dug up the site, you've seen what's in there, and you can add more information to it. And you should be doing that really, because you should always keep your CSM as up to date as possible. However, going back to the start, the first one in the early stages of your project, your desk studies, your CSM will be a very simple model. It could just be there's some contamination here. We'll also find it down here in a well. We think it's going from this. That's potentially a source. This is potentially a receptor in a ground in an aquifer. We think there must be a pathway between. That's fine. We don't know what it is yet, but that's fine. And that's the CSM. That is a model. That is saying that we think this is connecting to this, and that is a model, and that's absolutely fine. As the project progresses, however, and more information is collected, more of your observations are made, and your understanding of the site improves, your CSM will grow. and develop with more and more detail. And as the CSM develops, it is very important to be aware of not only what you know, what you understand about the site, but also what you don't know. You need to be identifying the uncertainties and the gaps in your understanding of the site and the source pathway receptor linkages from the point at which you start the CSM. You need to be starting to think about where your gaps are in knowledge are when you first start. And obviously, at the very beginning, your gaps will be huge. You probably know very little about the site, but over time, those gaps will get smaller and smaller and smaller, and eventually you'll have a CSM which works. You're going back to the sort of the idea of the model. You'll get to a point where your CSM is only wrong by a very small amount, and then you've got a really good model to understand what's going on. And this is really important because of one of our first rules we've got is uncertainties and gaps become the objectives of future site investigations. We can't take credit for this, but we can't quite remember where we first heard it. But it's one of the best things to remember when building a CSM. As your CSM develops, it'll be a process of filling in the gaps in knowledge on the site until you reach the point at which what you don't know doesn't matter. It's low risk, and then what you do know about the site is enough to do your risk assessment and begin design and remediation strategy. During the process of building CSM, you should be developing ideas and theories about where contaminants may be present, how they're moving from one area to another, and also what risks they may present to your receptors. And each of these sort of theories you can prove through well-designed investigation, putting a particular borehole or trial bit in the right location to test whether these theories are correct. However, second thing, which is quite key, is always aim to prove those theories wrong as well as proving them right. So it's one of these psychological things that humans have. I think it's positive confirmation bias, I think it's called. But you're always looking to prove yourself right or find someone which agrees with your understanding. It's very rare for people to look for things that prove themselves wrong. And you should always be looking to question your assumptions and try and prove yourself wrong as much as you try to prove yourself right. There are far too many sites that I've heard of and know of where assumptions about a site have been left unchecked and unverified and have been proved wrong far too late in the project cycle, which has cost people a lot of money, a lot of time, and you have to then go back and redo a lot of the work that's already been done because they've missed something, because they assumed they've made an incorrect assumption early on. Always, always, always verify your assumptions, and remember only to rely on what your data and what your observations are telling you. Okay. And finally, this was something which we also thought was very important, is the source pathway receptor CSM is fundamental. Okay. It's fundamental to everything we do on a site, but it is useless without what we're calling a conceptual understanding. There is always more to a CSM than just your source pathway receptors. You need to always understand everything else around those source pathway receptors and how they affect and impact the design and delivery of your remediation phase. So think about, you could get two sites with the exact same source pathway and receptor linkages, but they could demand very different remedial strategies because they're in different locations, they have different uses or different end uses, the contract type's different, they're in different countries, that could vary, and also they have different amounts of funding available. They're being developed for different purposes. Just because your source pathway receptors are the same does not mean you have to have the same remediation strategies, and that's where understanding everything else around it, where it is, what it's about, is crucial as well. And like I say, Sarah and I call this the conceptual understanding. So a quick word on the format. Every piece of guidance you pick up on CSMs will tell you that a CSM comes in three types: written description, a drawing, or a diagram, or drawing a diagram or a tableized format. And those are 3 ideas. I'll briefly go through the sort of benefits and negatives of each of those. So first one, written description. In 2016, I think, is the most recent one, the EA published this template for CSM, which is pretty decent. I've used it many times, the basis of CSM reports. It essentially lays out the source path and receptors for the site in a decent way, decent layout. We have a look at the contents page. So, we can see that it's structured to describe the sources in terms of things like site history, future plans of the site. It then goes into the pathways, receptors, taking into account all the different things that you'd be investigating, your geology, hydrology, man-made structures, etc. As well as taking into account things like pollution control measures that are already on site. Perhaps you have some sort of more historic pollution control measures that are already installed, already affecting how your pollution is moving across the site, already affecting how groundwater moves and that sort of thing. And it's pretty good. It's good for detailing. Reports like this are good for detailing all the information, putting down again all that detail down, as well as highlighting sort of unknown areas and for providing like a paper trail for decision making. However, as with all reports, they are hard to use for quick access to information. These reports tend to be very long once complete, so it is hard to sort of just pick it up and quickly reference something if you need to. So that's where perhaps the second form of it comes in, which is a nicely drawn image of the site, the sort of figure style, detailing all the key information. It's exactly the same information as what goes into the report. However, it's drawn out in a nice, sort of fairly easy sketch. Not necessarily to scale, but everything is in relative position to each other. So you can get a good visual understanding of your contamination, your pathways and receptors, and you can see what is being affected by what. And it's very good also for explaining the site to non-technical people, such as shareholders, that sort of thing. A lot of people can, once you can visualize like this, it's quite easy to get a grasp of the site, much easier than, say, with a written documents anyway. However, these aren't design drawings. They aren't perfectly drawn cross sections. It's very hard to use them for volumetric calculations or for even designing treatments, because they typically don't show sort of enough information, particularly in the way of quantities. Additionally, one of the big problems with this is a lot of the information is inferred. So, for example, the lithological boundary there between the natural drift deposits and the bedrock, well, that would be picked up by a few boreholes, but we don't know exactly where it is. So most of that line will be inferred by a geologist. But when you just look at it like that, it's not clear what parts of it are measured, where the wells went, where you know that bedrock is there, and what part of it are inferred. And that's the problem with this. You're looking at an image, but you're never quite sure what parts of it have been measured and what parts of it are maybe a little bit of artistic license, you know what I mean? So that's images. So the third type, the final type, is a tableized format. Again, the exact same information, sources, pathways, receptors, just laid out in quite an easy to read table. Very good for quick referencing, particularly for if you want to just check on what a specific receptor or a particular source, what the pathways and receptors are associated with that particular source. They typically don't have as much in the way of detail. And for complex sites, you can end up with a really, really long table, really long version of these. It's also, I personally find it very hard to visualize the site from a table alone. I know some people who love to have the tables because it really works with sort of how they think and how they're used to working. But for me, I just can't quite get the visualization down with it yet. But they are very useful. So each of these formats do have benefits, but they also have inherent issues. And as such, you typically find that most CSMs actually include a combination of at least 2 of these formats, more commonly 3. You'll find you'll have a CSM report with maybe a table in it and an image. One thing which none of the guidance that I've read anyway mentions are the 3D CSMs. Most of you listening right now, we think about probably early career practitioners. So you probably, I'm going to guess 20s or 30s, something like that. years old. So you're probably, like me, probably going to have another 30 years in the business at least. What we're going to see is, I believe, an emergence of three-dimensional CSMs as the norm, as the standard. The software and ability to create a CSM, so you create a 3D model of your site with all your different features, your groundwater, your hydrology, your geology, your subsurface structures, all that in a nice 3D model that you can look at and interrogate and work with. That software already exists. Leapfrog is probably one of the best ones. However, it's incredibly expensive and normally out of budget for the majority of practitioners, for sure. There are some open source and cheaper softwares that are developing. One of the newest ones I haven't had a chance to use yet, but I know is sort of trying to achieve this, is Groundhog by BGS. I downloaded a free version of it a couple of days back. But I don't exactly know how good it is, but maybe some of you have used it. But we're slowly moving towards this 3D version of a CSM, and I think that's exactly where we're going to get to, perhaps in the next few years at least. What is really good with this is that you'll also be able to incorporate real-time data, such as drone data, LiDAR data, which James will be talking to us about later on. But I think that's where it's going. So if you start having a look at using 3D software for your CSMs, because I think that's where we're going to end with this, or head towards this. So I think I'm still on time. So a few more slides. So what is the purpose of a CSM and why is it important? Okay. So the CSM has got loads of purposes throughout the life of the cycle. First couple, inform remedial design, obviously, is what's going to inform the designers what they need to do, what they need to do to treat the site. It's also going to be used to build the risk assessments, because you are risk assessing those SPR links, so source pathway receptor links. Additionally, it can be used to communicate and convey what can be quite a complex system underneath the site, to communicate that to stakeholders and non-specialists, members of the public, regulators, that sort of thing. So it can be used as a way of helping people understand exactly what's going on and exactly what the challenges are. It also provides a level of confidence to clients and authorities that you have an understanding of the project. The more you can show that you have filled those data gaps in, the more you can show that you have asked the right questions and done the right tests and done the right investigations to figure out exactly what's going on, the more confidence people have in the project, and the more confidence people have in you. And that is a really, really powerful thing to have. Again, it's used to highlight data gaps. That's the whole point. It's one of the biggest part of it is to be able to clearly show where you're missing information, where you're missing the understanding of the site. It's also used for budgeting and time scaling. So when you are starting to develop your remediation strategy, you need to start thinking about how much it's going to cost, how long it's going to take, that sort of thing. And finally, it's really important because many people outside of the investigating team, outside of these sort of consultants, many people will depend on it. We're going to talk about this in the breakout session later, but loads of different people are going to come to use it throughout the life of the project. And so it's got to provide them the information that they need. So I'm going to finish here with just a quick mention on what your responsibilities are, okay, as an author of a CSM. I've picked out sort of the top three, what I think, but certainly the first thing is to ensure that you have a thorough understanding of all the sources, pathways, and receptors on the site, and those are documented and assessed to a sufficient degree. So that is number one. Second thing is to ensure that all the data gaps are identified and filled to a sufficient degree, or you've identified them and recorded that and said, this is still a data gap, this is still unknown. We're either going to do some more investigation, or we're just going to accept that as a risk and move forward with the design. So you've got to ensure that you accurately show where the data gaps are and document them. And finally, as I said before, your CSM needs to be used by many people. So you've got to make sure it provides them with the information that they need in order to do their jobs as well as yours. So you need to make sure you provide the risk assessors everything they need to understand what the risks are, the designers everything they need to understand where the remediation is, how it's moving, where they're going to find it, what parts they need to dig up, or what parts they need to apply some sort of treatment method. And that's it. I've listed the most recent guidance for CSMs. That one came out last year, and I don't know if it has actually been accepted as standard yet, because there is a 2016 one which might be replaced. I think it's already replaced. But that's probably the best place to go if you want to get to have a look at the guidance, which I fully recommend. Okay, so thank you very much.
Perfect.